Hello everyone. Today in this video I am going to discuss about fast decoupled problems, which is the last part of load flow solution. We had already discussed what is Gauss-Seidel load flow solution, concept regarding that, and some problems regarding that. We had also discussed Newton-Raphson load flow solution and some problems and concept regarding that. Then we had discussed the comparison between fast decoupled, Newton-Raphson and Gauss-Seidel, and we had seen the concept of fast decoupled. Now let us see two problems on fast decoupled. The first problem will show you, which is an example with only PQ bus. The second problem had a PQ bus as well as a PV bus. So in this problem, if you see, there is two buses only. The first bus is a slack bus and the second bus is a PQ bus. So first step is we should find the Y bus in rectangular form. Then the imaginary part of rectangular form will give you B. You should also find the polar form. You should also convert that Y bus in rectangular form to polar form. As I had explained the reason in the conceptual video, we will see that also. Then you observe here which bus is the slack bus. First bus is the slack bus. So after getting Y bus, take the imaginary part of Y bus to get B. Eliminate slack bus row and slack bus column. That is first row and first column. So we will end up with only this element, that is B dash. Now if you had a PV bus, eliminate PV bus row and PV bus column from B dash to get B double dash. Since there is no PV bus, B dash is equals to B double dash, which is -4. Then the same thing, we should find delta P2 and delta Q2. To find delta P2, we should know scheduled power minus calculated power. For the residual power, scheduled power will be calculated from the given thing, that is 100 and 50. 100 plus J50, since it is a PQ bus, minus of 100 plus J50. And base value is 10. So minus of 100 plus J50 by base value 100. You will get -1 minus J0.5, where -1 is the scheduled real power and J minus 0.5 is the scheduled reactive power. Then the calculated power will be calculated using the formulas which are already derived in the Newton-Raphson. Using these formulas, we will be calculating the calculated powers for the 0th iteration. Then you will be getting the residual powers. Then for fast decoupled, as I had already explained you the derivation of the fast decoupled, this is the final formula obtained in the fast decoupled load flow solution. In this, we know B dash, we know delta P2, and we know modulus of V2, and we need to find del 2 of 0. So first we should invert it, and then we will multiply these two elements. Since there is only one element, you can multiply it, but actually P dash will be a matrix when we go for more than 2 bus system. And this delta P by delta V also will come matrix when we go for more than 1 bus system, 2 bus system, which we will see in the next problem. You should invert it, you should multiply, and there is minus sign also here. You will get del 2 of 0. Similarly, for finding del V2 of 0, we had this formula, minus B double dash inverse into del Q by modulus of V. So you substitute, and then you will get del V2 of 0. Now, as we had done in the previous methods, del 2 of 1 is equals to del 2 of 0 plus del 2 of 0, which gives you the first iteration angle for the second bus. Then V2 of 1 is equals to modulus of V2 of 0 plus modulus of del V2 of 0, which gives you the first iteration final answer. Now, considering these values, you proceed for the second iteration. The same problems which I had used in this lecture are also solved using Newton-Raphson load flow solution. To show the variation and to compare betterly, what I did, I had solved the same problems which we had discussed in the Newton-Raphson load flow solution. Again, I had used the same problems to solve using fast decoupled load flow solution. So I am going for the second iteration. You can go through this. Now going to the second problem, here we had second bus as the PQ bus, third bus as the PV bus. So this is P2 scheduled is minus 400 by 100 minus 4. Q2 scheduled is minus 250 by 100, that is minus 2.5. Then P3 scheduled is plus 200 by 100, which is 2. As I said, we will be taking minus for a PQ bus and plus for PV bus. Then they had given a slack bus voltage and angle, PV bus voltage. Now we should find the PV bus angle del 3 and the PQ bus voltage and angle V2 and del 2 using the fast decoupled load flow solution. So first of all, you find the Y bus. As I had already formed this Y bus in the Newton Raphson when I am solving the same problem, I took the final Y bus. From this Y bus, if you take only the imaginary parts, you will get P. And I also need to convert this into polar form. Why we should convert it into polar form? Because when we are calculating the P, for finding the residual powers, we should know the calculated powers. Then only we can subtract the calculated powers from the scheduled powers. In that calculated powers, we will be using theta 22, y22. Those things are obtained, substituted from this polar form. So the rectangular form is used to obtain the B, and the polar form is used to obtain the calculated values of real powers and reactive powers. After finding B, as I had already mentioned, to get B dash, you should eliminate first row and first column. Why? Because slack bus row and slack bus column. Since the slack bus is in the first bus is the slack bus, eliminate first row and first column to get B dash. Now from this B dash, otherwise from the B, you eliminate slack bus row, slack bus column, as well as PV bus row and PV bus column. That is first row and first column, third row and third column to get B double dash. After getting B dash and B double dash, again, you should find the scheduled power, thereby residual powers. After calculating residual power, see the residual powers, we had Y31 cos theta 31. This Y31 is the magnitude of the 31 element, and this cos theta 31 is the angle of the 31 element. These Y31 and theta 31 will be obtained from the polar form of the Y31 corresponding rectangular form element. This del are the angles. Del 3 is the V3 corresponding angle. Del 1 is V1 corresponding angle. So you will be obtained with this. Then now if you see what is the equation, del is equals to minus B dash inverse into del P by V. But here we need to find del 2 and del 3. Since del is unknown for both PV bus, that is second bus, and PQ bus. Sorry, PQ bus is second bus, where del is needed to find, and PV bus is third bus, where del is an unknown. So you should find del 2 and del 3, which is equals to minus of, this is B dash inverse into del P2 by mod V2 is this element, and this is del P3 by mod V3. So you will get del 2 and del 3. When we are finding V2, since first bus is a slack bus where V is known, and the third bus is a PV bus where magnitude of V3 is known, we will be having only one element V2. V2 is equal to minus B double dash inverse into del Q by del V. So minus, actually this is B double dash inverse. So I directly wrote. Otherwise you can take B double dash inverse. What is B double dash? What we had got? B double dash is minus 52. If you invert that minus 52, you will get this 0.0192. So minus 52 inverse into del Q2 by mod V2. What is del Q2? Del Q2 is minus 0.2175. Mod V2 is 1. Why? Because flat start. So minus 0.275. Now we got the values. So del 2 of 1 is equals to del 2 of 0 plus del 2 of 0. Del 2 of 0 is this term, and del 2 of 0 is 0, flat start voltage. Similarly, del 3 of 0 is 0, flat start voltage. Del 3 of 0 is obtained here, minus 0.0084. So you will get these values. Now V2 of 1 is equals to V2 of 0 plus del V2 of 0. This V2 of 0 is 1. Then why? Because flat start voltage del V2 of 0 we had already obtained, which is minus 0.0042. So with this, I had explained a problem on PQ bus and a PV bus. So thank you.